So in this video, we are going to work on the final exam review part 2. You will see this one is shorter than the first part. This is 25 questions. We'll see if we get through all of them in this video or if we don't. And we'll see. Okay, it says, suppose a rock is thrown upward from a bridge into a river below. The height of the rock above the surface of the water is given by the function you see there. T is the number of seconds. So let's kind of make ourselves a note that f of t is feet and that t is seconds. And how high is the bridge? Well, if we are standing on a bridge and we're getting ready to throw it, the rock is currently at the height of the bridge. So if you plug in 0, that's always going to be your initial height. So if you plug in 0, you get 163. How high above the water is the rock in 0.5 seconds? Well, is plug in 0.5. Now, be careful when you do that, but you should be able to just do that in your calculator. So you'll do negative 16, excuse me, times 0.5 squared plus 44 times 0.5 plus 163, which is 184.96. If I entered it right. So we're going to submit just to make sure things are going good. Let's see, what did I not? Oh, all right. I put my decimal place in the wrong spot here. That does change things slightly. Oh, much nicer answer. Sorry about that. The answer is 181. Okay, that should check that one. Okay, next, how many seconds does after how many seconds does the ball hit the water? Now, anytime you are going from a certain height and then you're hitting the ground, the water, whatever that case may be, that is when your equation is equal to 0. Now, I don't like the fact that our highest power is negative, so I am going to multiply everything through by -1 before I use the quadratic formula. Now, if you can clearly see that it is a factorable quantity, go ahead and factor it. But in this case, I am going to just use the quadratic formula. It'll probably save me time. So remember, your quadratic formula is -b plus or minus the square root of b squared minus 4ac all over 2a. And so our b is -44, so that's 44 plus or minus the square root of b squared. Now, 44 squared, I would probably just throw that in your calculator. That's 1936. And now you're going to do, I would do -4 times our a value of 16 times our c value of -163. Find out you get a positive 10,432. All over 2a's. Now a is 16, so just make that 32. Now let's get a number inside here. That 10,432 plus 1,936 is 12,368. Which isn't a perfect square. Now, if you do the subtraction portion, you get a negative number. We're not going to go backwards in time to hit the water. So we're going to use the positive version. And so if you were to put that, I'm going to just, since it didn't say to round, that exact answer into iMath. So I'm going to do in parentheses 44 plus the square root of 12,368. end all those parentheses, look at your preview, all divided by 32. And just check out your preview. Is it what you have written on the page? And let's hit submit. Perfect. Now, how many seconds does it take for the rock to reach its maximum? So I'm going to draw a little picture. Okay, so we're standing on a bridge. We're throwing in an arc. We're hitting the water. Okay, so think about any time they mention maximum or minimum of a quadratic, you have to get into your head that maximum implies vertex. Okay, so when it says how many seconds, that's the t. What's the t or the x of our vertex? Well, the x or t in this case of our vertex is always negative b over 2a. We have those same negative b was 44. 2a's was 32. It is this portion, let me show you. It is this portion of your quadratic is always your vertex's x. So let's just put that in there. Okay, so 44 divided by 32. Okay, now what is the maximum height? Well, the maximum height, the maximum value of whatever your function stands for, in this case feet, is the y value that goes with the t value we just found. Now, it would be f of plugging in 44 over 32, but since iMath doesn't care if we just plug in the whole thing, if it doesn't use the word round, let's just plug it all in. Okay, so I'm going to do negative 16. Then, in parentheses, 44 over 32 to the second power, plus 44 times 44 over 32, plus 163. And that should be the y value. Now, if this was my question and they said round to the nearest whole foot, I see the number 193.25, I would use 193. So you can let iMath do some of that calculation for you. It's like entering it into a calculator. So there we go. So that is question number 1, a parabola application problem. Sorry, I didn't hit there. It's number 2. Okay, let's look at number 2. It says determine the vertex of the following quadratics. Express your answer as an ordered pair xy. I'm going to do B and C first because B and C, I think, will lead us to what we need to do in A. So let's start with B. I'm going to write it as x squared plus 0x minus, and I'm going to make it 16. Okay. They were trying to show you that that was a difference of squares. Okay. So, there you go. Okay. So, if we use what we know about finding the vertex of a parabola, we know the vertex is x is negative b over 2a. We know the vertex is y. We're just going to plug this value in once we find it. So if we plug in, that would be negative 0 over 2 or 0. So we really just get to plug in 0. And when we plug in 0, we get negative 16. So our answer to B is a really nice one. Our vertex is 0, negative 16. So let's put that on there. As an ordered pair, so you would need to use your parentheses and then submit. Okay, now I'm going to move on to C. Now, we're going to do the exact same technique. First, let's find negative b over 2a. So our b value is negative 1. Our a value is 6. So our x value is 1/12. And our p of 1/12 is just 6 times 1/12 squared minus 1/12 plus 9. Okay. Now, how could we put it in? I'm going to see if they like this. I don't know. But I'm going to put in 1/12, comma. And then I'm going to put in that thing I just wrote down. 6 times 1/12 squared minus 1/12 plus 9. Now, it has some weird little things there, but I do see a number in both locations, okay? So let's try it. Perfect. Okay. Now that moves on to A. Now, you might notice that the difference between B and C is that standard expanded form. A is in factored form. So my suggestion to you, there is a way for us to use our factored form, but I think we're just going to multiply it out, okay? So I'm going to get negative 60x squared. I'm going to get 100x plus 18x, or 118x. Now you can do this all in 2 steps. I'm just doing it in one to save space and time. And then that's negative 30. So that's your standard form. And now we're going to do exactly like what we would do for B and C. You just do negative B over 2a, plug it in, there you go. Okay, so now let's move on to question 3. Determine the roots. Now, roots are different than our vertex. Roots, we want the factored form. So I am going to do 2 different questions for you. I might do all, we'll see. But A, the roots, remember, are where our factor equals 0. So that's a root. So a root is the same thing as a 0, is the same thing as an x-intercept. So in A, we can just set negative 3x minus 8 equal to 0. You just want to solve that. You get negative 8/3. And then you can set x plus 7 equal to 0, and you get negative 7. So you're just going to put negative 8/3, and then your next one, separate it with a comma, and then put the next one. Okay. So factored form's nice, okay? Now, B can be factored because it is the difference of squares. So that's just x plus 6 and x minus 6. So we have factors of negative 6 and positive 6. So we would just put negative 6 and positive 6. Now, C, if it is a factorable quantity, that's the easiest way. If not, you can find factors by using the quadratic formula. So let's look at C. Let's see if that factors. I'm going to use a technique called slide and divide. I'm going to slide the 10 over. I'm going to multiply it by the 14 that you see in the back. I'm going to call that 140. Okay. Now, how did we get 140? Well, that's 14 times 10, which has a difference of 4, not 13. So it isn't helping us. But 7 and 20 sure does. 7 and 20 have a difference of 13. So that would be x plus 20 and x minus 7. Okay. So what did we slide over? I slid over the 10. So you divide by 10. If it's divisible by 10, that's your completed factor. If it's not divisible by 10, make sure that fraction is reduced. Stick your denominator on your x. So those are the factors. Now, once I have the factors, I can solve. So this would be a 0 of negative 2. This would be a 0 of positive 7 over 10. Let's see, make sure I didn't make any mistakes there. So there is C. Now, D, the factors of 18, let's think of that through a little bit. The factors of 18 are 18 and 1, that adds up to 19, not 9. 9 and 2 adds up to be 11, not 9. But 6 and 3, so it's a factorable quantity. That's always the route you want to take. That's x plus 3 and x plus 6 for roots or zeros at negative 3 and negative 6. So that is question 3, finding roots. If all else fails, use the quadratic formula. It says, assume the 0.46 is on the graph, determine the value of n in the following situations. So it says 4n is on the graph of y equals 2 f of x. Okay, so I'm going to write down the point. And it says 6 was our original graph. So what would be the value of n in y equals 2 times f of x? Well, when the 2 is on the outside of a function, you're just going to change the y value by multiplying by 2. Our original y value was 6. Now, so this would change. It would become a 12. This one would multiply that y value by 3. So 3 times 6 is 18. We'll check those first just to make sure that they were on the right track. Now, 4 adds 2 to our y value. So our y value originally was 6. Now our y value is 8. And then this one, we have a few more pieces to do. It's just, multiplied by -3. So -4 minus 3 times 6. That's all you're going to do. So -4 minus 18 is -4 minus 18 is -22. So there is one. They're just really manipulating the outside of the function, which changes your f of x value or your y value. And they're just talking about that's a transformation. Seems harder than it was, but it says the following functions in terms of f, where y is equal to f of x. The value of the functions g are always twice as large as the corresponding value of f. So g, and I don't know if we want to put f, we're going to experiment here, equals 2 times f of x. And let's see. Okay, now we're using h. H is 4 more than. So h of x, we are going to take our f of x function and we're going to add 4. So again, these are things that are happening to the outside of our function, okay? Here we have a graph. We are going to match it with the graphs below, okay? If you hear in the background a kitty cat, that is my old kitty cat. His name is Smokey, and he is deaf, and he meows just to see if we're around, and I'm not sure why, but I'm not torturing a cat in this video. There is a cat somewhere that is probably meowing at me. Okay, so the first thing I would notice for this is the one that has a negative on the outside, the second one that we see, is going to flip that function over. So see how the ends are pointing up? Go down, the only ones where the ends are pointing down are D. So we know for a fact that this one would flip those ends. That's the only one. So we can eliminate D right off the bat. That's the easiest way to do that. Now let's look at the third one down, f of -x. That's going to take the graph and flip it over the y-axis. So now this low bump that's on the right will flip and be on the left, and the little bump on the left should be on the right. So let's look for where a low bump is going down, and I think that is our B graph. So that's this one. So let's eliminate those. Now our first transformation is our function has moved down 2. So see how our low bump is about at -3. Let's try to find where that low bump is down about -5. And the only one I see where that happens is C. And then we should have A is our answer to the last one there. But let's just check. See how we hit the x-axis at -3. That little dip there at -3, that relative minimum. See how it scooched to the right, 2 jumps to -1, and that can verify that that's what's happening. So that's a little bit about question number 6. Oh, let's submit just to make sure. Perfect. Oh, something not perfect. Oh, I'm sorry. I didn't hit this one. I remember that one was A. Okay. So now let's go to question 7. So we've got this function. It's kind of just like a piece of an absolute value. They have told us our domain goes from -2 to 1. So it's just going to go from -2 to 1. Our range goes from -1 to 1.5. And then determine the range, domain and range of these things. Now, A is just a repetition. Keep the brackets on it. So -2 comma, oh, sorry, I say that. I don't hit a normal bracket. -2 comma 1, they gave us as our domain. And -1 comma 1.5, they gave as our range. So let's just check, make sure we got it. Okay. Okay. Now I'm going to use, I need to write some stuff down. And this is my suggestion as you do this problem. Okay. So let's make this a little bit bigger. Okay. Now the next one would flip it, see how the negative is by the t. So B is going to take our domain. I'm going to write the domain out. -2, 1, and -1, 1.5. And the thing is in B is by the t. That's our domain. And so it's going to flip it. Now, if we flip those values to be 2, -1, that is not in least to greatest order. So physically flip it. So it's going to be -1, 2 is our domain. We have not touched anything on the outside of our function. So our range value will not change. So keep it that -1, 1.5. Okay. Now, if there's a negative on the outside of the function, we are flipping the y values or the range. So keep your domain, -2, 1, but let's use our new range is going to be -1.5, +1. You see how I multiplied by -1 and flipped it? Let's put that in. Now the old kitty cat is running around the halls of my house, being silly. Silly, silly. Okay. So now let's just check those ones just to make sure everything is awesome and grand. Okay. Now let's look at D. We are adding on the outside of our function. Anything done on the outside is going to change our range. So write in your domain again. Domain will not change. So -2, 1 is our domain. Now, but our range. Take your range values of -1 and 1.5, add 3. -1 plus 3 is 2. 1.5 plus 3 is 4.5. So it just lifts it up 3 units. Okay. E. Two things have happened on the outside of our function. We have to flip it and add 1. Now remember, we already flipped it in C, this one right here. So for E, if we flip it, we got the -1.51. But now we need to add 1 to both of those. So we would get domain, nothing's changed, -2, 1. But our range is now going to be, if you add 1 after we flipped it, it's going to be -0.5, comma 2. So we'll check that one. That one's a weird one. Okay. Now, what I would suggest doing for F is the hint they've given you. Okay. So it's on the inside. It is only going to be affecting our domain. So let's put our original range. Remember that -1, 1.5. Let's put our -1, 1.5 in so we can just move on to domain. Okay, so what were our original domain values? Negative 2, 1, right? So where would negative t plus 2 equal negative 2? And then where is it going to change it to? Where is it going to move it to? Where is negative t plus 2 going to change our 1? Okay, so we're going to do each one of those. It's just an equation. We'll see where our domain starts and where it ends. Okay, so if I subtract 2 from both sides, I get negative t equals negative 4, so t is 4. So now our domain is going to start at 4. And now here, if we have to turn it, because I see that negative there, I think it's not going to be in least to greatest order when we're done, so we will fix that. Okay, anyway, we're going to subtract 2 from both sides. We get negative t equals negative 1, so t is 1. Do you see how it's not in least to greatest order? So now just turn it. So our domain would be 1 to 4. I only usually have to do that when you have a lot of things going on with the inner piece of your function, with your domain values, because it's just hard to see otherwise. And when we get to trigonometry, that's a trick we're going to use quite a bit. So here we have two things going on. The negative on the outside is going to still change around our domain or range values. Remember, our range was negative 1, 1.5. So now we're going to make it negative 1.5, comma 1. Okay. Now, but remember our domain was, now I'm going to peek here, our domain was negative 2, 1. So the t minus 4, where is t minus 4 going to affect the negative 2? Where is t minus 4 going to affect the 1? We should instinctually know that it's going to move it to the right, because we're going to add 4, it's going to become 2. We're going to add 4, it's going to become 5. So our domain is now 2 to 5. Okay. So that is a rather complicated, kind of strange process. But if you just think instinctually, is it affecting my domain or my range? Do it to those values to make sure it's in least to greatest order, and then you got it. Question 8. What are the roots of the polynomials? Roots of polynomials are easiest found by getting in factored form. So a and h are going to be our quickest to solve. We can do it without really even putting it on the side of the paper. Don't forget for a, 3x equals 0 at 0. 7x minus 5, if you solve that, you would move the 5 over. It would become a positive and then divide by 7. And then lastly, we would have negative 2 divided by 2, or negative 1. So if there's an x out front, don't forget that's a 0. Same thing for b. The x squared gives us a 0, then a positive 7, and a negative 6. So the factored form is what you want. You see how quick we're able to solve it when in factored form. So now let's go to C and D. Let's put those in factored form and get those all ready. So 54 is 9 times 6. So that would be x plus 9 and x minus 6. As soon as we know that our zeros are negative 9 and positive 6. Now D, I noticed that everything is divisible by 2. So my suggestion would be, hey, pull out that 2. Make that easier so that the factorization becomes much more natural. So my factorization would be x plus 5 and x minus 1. Now 2 is not going to equal 0. You don't need it. There's nothing there that's worth doing anything with. But you do need the negative 5 and a positive 1. So there's question 8. It says define a polynomial function with degree 3. So we're going to need 3 factors that have roots of negative 12, 6, and negative 13 and passes through the point 0, negative 1. Now the first thing you want to do is set up your roots. So we're going to put a little a here. That's our placeholder. And then we're going to set up our roots. X plus 12. See how it changed? x minus 6, x plus 13. And then we want to go through the point 0, negative 1. So when I plug in 0, I need to get negative 1, okay? So think about the fact that if I plug in 0, I should get negative 1. So if I plug in the k of x is negative 1, or your y value, and this is a, 12, negative 6, and 13, because 0 plus 12 is 12, 0 minus 6 is negative 6, and so on. So a is just negative 1 divided by 12, divided by negative 6, divided by 13. So the two negatives make a positive. 12 times 6 times 13 is 936. Okay. So what's your equation? Well, all you got to do is take out the a placeholder, replace it with this, use all that. We got it. Okay. So let's write the whole function. K of x equals 1 divided by 936. I'm going to put a little space there so that fraction kind of is there. Okay. And then parenthesis, x plus 12, parenthesis, x minus 6, parenthesis, x plus 13. And then let's submit. What did Mrs. Hart do wrong? Oh, I'm sorry. I somehow did not get my minus in between there. Let's try again. There you go. Always hit the preview, Mrs. Hart. Always hit the preview. I didn't hit my preview. There you go. Let's go on to 10. So this is about our lead term. What are our end behavior? What are the ends going to do? Are they going up or down? Okay. So let's start with A. It's in multiplied form. So A and C are the same. So I'm going to do A and C. Or I'm going to do A, you do C. So our lead term is our highest power, which I see is a negative. It's not in order. So negative 15x to the 11th is my lead term. Okay, so that is a odd powered polynomial. So one goes up and one goes down, but the negative flipped it. So now the left goes down and the right goes up. So as x is getting higher and higher without bound, that's our right end, it's going down, it's decreasing. But our x decreasing in our left end is going up, it increases, okay? Now, so that should enable you to do C. A and C are the same. Now let's do B. So I'm going to pull out the x's and the powers from everything, okay? So I got a 20x, I got an x, I got an x, I got a negative 7x. I got to pull that out, but to the third power. Okay. So now let's kind of put that all together. 20 times negative 7 to the third power is a big number, but let's write that down. We can get that from our calculator. Negative 6860. And then if I count up all the x's, I have 3 kind of individuals and then 3 in the parentheses, so I have an x to the 6th. Now normally, an even power both point up. Unless I put a negative in front, then they both point down. So let's put in our lead term, negative 60. Oh, not that one. This is hot. How about, oh yeah, that was on. Negative 6860, x to the 6th. Okay. Now I'm just going to check that so I didn't do something funky mathematically. Okay. Now that means that our right end is decreasing, going down. Our left end is decreasing, going down. So both ends go down. So that's question 10. Let's look at question 11, which is the interval where the function is positive and negative. I'm going to do A for you, and I am going to do A by drawing a very rough sketch of the graph, which is going to probably help with later things anyway. Okay. The lead term of this is all the x's together, or x cubed. So I know the right end goes up and the left end goes down. Something like that. I have a 0 at -3, at 2, and at 6. So I'm going to make a very rough sketch. Don't make it, it's not going to be pretty. It's going to be a very rough sketch. Okay, so -3, 2, and 6. Okay, I know the left end goes down, the right end goes up. None of these are an even multiplicity, an even repeat, so it just goes through, through, through. Okay, okay. So now we can answer the question. Where is the function positive? So I'm going to highlight that in pink. So from an x value between -3 and 2 and after 6, so on an x value from -3 to 2, my graph is above the x-axis. Put your U for union. And then from 6 to infinity, my graph is above the x-axis. And so that would be where my graph is positive. Now I'm going to highlight in kind of this green color where my graph is negative. So that would be the x values from -infinity to -3. It keeps trying to correct my union from 2 to 6. Because remember, those are your, on what x values will the function be above the x-axis? Positive. On what x values will the function be below the x-axis? Negative. That's what they mean. And so you can finish B by yourself, same thinking. Make sure it's in factored form. Draw a picture of the graph. If there's a bounce, make sure there's a bounce. Okay. And the last one we're going to do is 12. We will split this up and do the last remainder in a fourth video. Okay. It says, which of the following are roots of this function? All we're going to do is we are going to plug them in and see if we get 0. Okay, so that's what we're looking for. So if we plug in -4, let's see what we get. So get out your calculator, put your -4 in parentheses to the third power, minus 17 times -4 in parentheses to the second power, and so on. And we get -560. So that's definitely not a 0, not a root. Okay, so that one's out. Now let's plug in 1/2. So I'm just doing the same thing I did before. Instead of plugging in -4, I'm going to plug in 1/2. Let me just make sure I did it. Okay. Yep. And I got that f of 1/2 was -24.5. So that's a no. So now I'm going to do it again for -1/2. Give me a second here to plug in -1/2. Almost there. Okay, and I finally get a 0. So I'm going to click that one, but it could have multiple zeros. That's a third power polynomial. It could have 3 distinct zeros. So let's try one more. Let's try negative 2/3. So if you plug in negative 2/3, let me tell you what we get here. We get 0 again. So we would check mark both of those. So we're going to stop there. You will see a fourth video for your review sometime maybe tomorrow. Okay, thanks.